Everybody, welcome to week 3, our final week of PLIX Urban Ecology Online. Today we'll be doing understanding urban soils. Again, my name is Lydia.
My name is Avery.
Hey, I'm Catherine.
And we're super excited to have you all back this week. So let's just do some forward thinking about upcoming events. We have Space Food coming up in 2 weeks, where we'll be doing a similar workshop to this on our Space Food activity, and then having some more workshops announced soon. You can RSVP with this link, and then what we're up to today, our agenda. We're doing a little welcome right now. Avery is going to give a short presentation on the wonderful functions of soil. He's been very excited about this activity since the start of this. We'll be doing an activity overview of understanding urban soils and talking about some facilitation tips around this activity. We'll be having a similar breakout discussion to the last 2 sessions, and then we'll do a little wrap up, share out. We'll answer any questions about the activity or anything else, and then that will be the hour. So Avery, take it away.
Great, so welcome back everyone to week 3. As Lydia stated, this is my favorite activity, mostly because I love to get my hands dirty and dig holes. So I hope you share that passion as well. So this week is all about understanding urban soils, and within that, answering the questions related to how do we determine different soil types, how do we know what soils are doing, how do we know what their functions are, and how do they support life, and what kinds of life can they support. And so soils are important for so many different reasons. I like to use this quote from Anne Weston Spurn, which is, "Soil is the crust of the earth in which life is rooted." So quite literally, soil is a scaffold biologically and physically for almost everything that we see in the city and in the suburbs. So here are quick examples of different functions of soils. They are filters, grabbing pollutants from stormwater. They help to recycle organic material and decomposing material into organic matter, making future fuel essentially for future organisms. They're habitats, of course, for again, plants and animal species, and also us, frankly. And related to that, they're also foundations for the various buildings that we construct. If we think about the climate change, then the soils become even more critical because they are carbon sinks. They absorb carbon that we produce into the soil and actually help reduce environmental levels of carbon that help to heat the atmosphere. And finally, soils are regulators. They sort of help to temper or buffer different environmental storm conditions, for example, storing water for later use. And so to hone in on a couple of various functions, I used your examples this week from the prompt, which was to collect soil samples from around your neighborhood, but also take an image of where those soil samples were collected. So the first point is that soils are ecosystems. So Emily St. Germain of Cambridge provided this example where she analyzed 3 different soil samples. So props to Emily for collecting 3. And what I want to convey here is the diversity of things that can be found in soil, which seems pretty obvious. So in this example, you have an A, which is an urban garden, B, which is a giant tree growing, and C, which are some more carefully planted shrubs. And in this, you can see that there are 3 different soil types here. They have different compositions, as you can see from the soil shake, and they're supporting different plant species. And so we start to understand that there's a connection between the way that a soil looks and the type of life that it can hold. And importantly, soils are, in this regard, sort of a litmus test for the health of an ecosystem. We can look at plants and trees and sort of determine immediately if the soils in a place are of high or low quality, given the types of life they support. On a related note, soils are relatively easily damaged. So sometimes soils or healthy soils are referred to as endangered species in city communities just because there are so many environmental stressors that can affect the way that they operate and their health. Things like acid rain and nitrogen deposition and even pedestrian traffic can compact soil and acidify soil, which makes it a hostile environment for most species. So Lydia was the lucky example today for providing a damaged soil sample. We'll talk about the specific composition a little bit later on, but you can see that even just from looking at this, there seems to be a lot of sand. And just looking at the image, you can sort of tell that the soil texture is really stuck together and relatively compacted. So this is sort of what we don't want necessarily in city ecosystems. However, they are commonly found, but it is good to note that there are still plants growing in them. Like we discussed in the previous session, or if you're new to this session, these sessions, plants in urban environments are pre-adapted or stress adapted to thrive in these hostile conditions. So while it is an option for plants in cities, this is sort of just a way of understanding that this is a chance for improving soil quality. We can only sort of go up from here. And with that in mind, soil systems can be restored. So, it's not a sort of irreversible process, the destruction of soils. And Thomas from Denmark gave a really good example of this, in which he demonstrated compost from his garden. And composting is just one way to recycle or create new soils or provide new substances in soils, which sort of revitalizes their capabilities to act as habitats or scaffolds. And so when thinking about soil systems and how they can be restored, it's more of a process about remediation, in which you can use healthy soils, sort of like the first ones we looked at, as examples. And you can actually transplant different soils to different places to make them more healthy. You're bringing along sometimes microorganisms or different chemicals in the soils, and eventually those sort of balance out and can actually restore the functions of the soils. And so in this process, we all created different soil shakes. And so why do we care about a soil shake? So soil shakes actually allow us to determine the composition of a soil sample. And of course, there are more technical analyses that can provide, picture perfect analysis, but this is a really great way and a perfect example of just a quick and dirty read that is often pretty accurate. So when we do a soil jar or a soil shake, what we're doing is separating out soil into its three major components: clay, silt, and sand. And the reason that these separate out is because of their particle size, with sand being the largest and clay being the smallest. And so when you do a soil shake, the sand and silt often sort of fall to the bottom pretty rapidly, whereas the clay takes a little bit longer. That's why we try to do like an hour to allow all the components to settle down. And basically, the relative quantities of these different soil components can tell you about the health of an ecosystem. But not only that, but also the types of life they can support. So in an ideal scenario, you have about equal quantities of sand, silt, and clay, and that's often called loam, which you'll find in gardens. So we'll see an example a little bit later on. But sometimes you have pure sand, which is maybe something in a desert. So, or something that is pure clay, which is something along rivers where you might see a willow tree. And so different plant species can survive in different relative quantities. And so when trying to get a picture of your ecosystem, of your local community, getting a read of what types of soils are present and correlating it to the types of life you find can be a really exciting exercise. I also want to mention the soil texture triangle. So this is a tool that's used by the US Department of Agriculture. It seems pretty scary, but I swear it's not. PLIX has created its own simplified version. You'll also find this in the zine for this week, this activity. And basically, this is another way to look at your soil samples. And so the way to do this is to get the soils in your hands and try to determine if they're more clay, sand, or silt heavy. And from there, you can use the relative percentages of these different materials to determine where on the triangle it falls. And so the theme of this week basically is not only learning to characterize soils in these two ways, but also seeing how something like the soil texture triangle and the soil shake can tell you about this plant species that are growing within soils. So as we turn to the workshop, Understanding Urban Soils, I have a couple of facilitation tips that I think will help to get you through the week or through the activity, while providing some really interesting questions and modeling techniques that will be super helpful. So the first facilitation tips relates to engaging varied habitats. So much like Emily's soil example where she chose 3 different soil samples, it can be helpful for patrons to understand soil in many different contexts. So when we ran this original playtest, we did soil collections near a basketball court where there was basically only rocky and sandy soil. We then headed toward a park area where there's a lot of mulch and dirt underneath there. And then finally, along a sidewalk where the soil had been extremely compacted. So these 3 different environments, and you can do as many as you want, provided 3 very distinct soil profiles. And of course, from the images, you can also see that there are very different species growing in them, or in the middle case, no species. So engaging these varied habitats, diverse habitats, helped us to see, even within a small range, the different types of soil that you can collect. And understand that soil is like a microhabitat. There are different pockets of different soil types all throughout the library grounds in this case, or around your community. So making sure that when you plan your walk, you're offering an opportunity to collect many different soil habitats. It's also super interesting to explore managed or curated spaces. And what I mean by that is sort of intentionally planted or managed spaces like a garden, a community garden, or a community park where there are maintenance efforts. So this is an example from Catherine's community garden in Cambridge, Massachusetts. And I use this as an example because the soil shake has a perfect distribution of sand, silt, and clay. So up to that sort of light gray layer is sand, and then there's a darker patch of silt, and that light ring of brown on top is the clay. And so this is what we call loam, this magic quantity of sand, silt, and clay. And so why this is interesting is that it sort of serves as the antithesis of what we observe often in urban soils. This is the sort of place that we want to get to for urban soils in terms of optimal growing conditions for species, but also for ecosystem and soil function. And so in addition to the diverse habitats, sort of building off of that, trying to include somewhere where you see this management, you see this upkeep of the environment can be a sort of nice counterbalance to the stress environmental systems that we observe with standard urban soil systems. My personal favorite facilitation tip is to encourage feeling in addition to collecting. So while you will be digging holes and putting dirt into jars to do the soil shakes, nothing can sort of replace the tangible aspect of this, of the soil analysis. So we do 2 different types of analysis. The first is called clumping, and then the second is called rubbing. So soil clumping is simply where you take a bunch of dirt and you clump it in your hand, and you see basically how well that soil clumps to itself. In the first example up top is a really sandy soil sample. So you'll see that it doesn't clump very nicely. There's not a lot of moisture retained, so it kind of just falls apart. But on the bottom there, we see a really clay-heavy soil sample. And so when you clump it, it sticks together. Those clay particles are wet, they're happy together, and they really want to stick together. And so this, in addition to the soil shake, is a quick and dirty way to determine the moisture and particle size of the soil samples. And it's also just fun to get your hands dirty. You'll also use the field journal, again, to not only collect observations and collecting about the species that you're finding there and testing, but you can also include or encourage your patrons to include simplified versions of the soil triangle again. So the other analysis technique that I want to talk about is rubbing, and you'll do this in the initial exercise, but you can also do this in the field. And the rubbing is a modified version of clumping, basically, where you're taking or using a sheet of paper to rub the soil into its smallest components. So this not only gives you a sort of color test to see what perhaps nutrients or chemicals are present in the soil, but is another way to get at that particulate size to see what the smallest particles are in a particular soil sample. And that's just another way to determine clay, sand, or silt. And again, just continuing to engage the field journal so that you can include specimen samples building off of previous weeks, or if you're running this on your own, or running this as a standalone workshop rather, making sure that you're including the plant species and observations that you find, in addition to soil rubbings or just the physical jars containing soil samples. So those are the facilitation tips for this week. I think we'll head over to the breakout sessions now, and I'll turn it over to Lydia and Catherine if they have any comments about the breakout rooms.
Great, thanks, Avery. I mean, I think we kind of all know the drill by now, but the breakout rooms will open briefly right below this video. Please feel free to hop in any room that you choose. We'll be there for about 25 or 30 minutes, then we'll come back for a wrap up, which will also include sort of some reflections on this entire 3-week process. So thank you so much for those of you who have been with us the whole time. Yeah, I think that's it from us. So see you in a bit. Thank you.